Linear equations. Solving linear differential equations. It's pretty fun. So here we go. A first order linear differential equation is one that can be put into the form dy dx is equal to p of xy, plus p of xy is equal to q of x. So you can think of this as dy dx or as y prime plus some function of x times y is equal to some function of x. All right, so if you can get it in this form, then that's a linear equation and you can solve it. So right here, I'm about to do something that just is a little bit, maybe just a little bit mysterious, but in just a second, I'm going to take all of the mystery out of it for you and show you exactly where everything comes from. So if we have to solve an equation like this, and again, I'm always like start this without my notes. Let me get my notes just a second. All right, if we got to solve a linear differential equation, notice that you cannot do what we did before. You can't rewrite this into a factored form where you can get all the x's on one side and all the y's on one side and separate it as we did before. So we have to come up with another way to solve these, and so people have come up with a really good way to solve these. So first I'm just going to show you it. Suppose that I multiply both sides of this equation by x to the fifth. I'm just going to multiply both sides by x to the fifth. Now, in a minute, I'll show you how I came up with this. But for now, we'll just have to go with it. So if I do that, I'll get x to the sixth y prime plus 6x to the fifth y is equal to 7. X to the sixth times x to the fifth is x to the 11th. All right, fine. What did that do for me? Well, if you look at the left-hand side, this is actually the derivative of a product of functions. This is actually the derivative of x to the sixth times y. So if we go through this, I'll just say it out loud. First function times derivative of the second plus second function times the derivative of the first. The derivative of x to the sixth is 6x to the fifth. That is exactly what this is. This is the derivative of x to the sixth times y. I didn't do anything to the right-hand side. I'm just copying it down. But now if I notice that, what I can say is, oh, okay, I'm going to integrate both sides. All right. So if I integrate both sides, what's going to happen here? Well, if I integrate a derivative, I just get the integrand back. All right. On this side, I will integrate with respect to x. I'll get 7 over 12, x to the 12th. That's what I get. Then the job is to find the unknown function that will satisfy this equation. So I'm solving for y. So to further solve for y, oh, I forgot my constants plus a constant, right? So to further solve for y, I will divide both sides by x to the sixth. So I get y is equal to 7 over 12 x to the sixth plus c x to the negative 6. And this is a solution that will solve this differential equation. So what in the world just happened here? What happened here was I multiplied by something special that would put it into a form where I could take, I could recognize this as a derivative and then integrate to solve. So if you can write your equation and you recognize that it's a linear differential equation, and you recognize that because you can put it in this form. If you can put it in this form, then it's a linear differential equation. And if it's a linear differential equation, there is a special thing you can multiply both sides of the equation by called an integration factor. And the integration factor is equal to e raised to the integral of p of x dx. And so what this does is once you find that integration factor, you can multiply both sides by that, and it will be in you will find it's a product rule derivative on the left. So What did I do? Well, if I was given this, I would first get it into this form. So I divided everybody by x so I could recognize it. So y prime is the same thing as dy dx. So y prime plus 6 over x times y is equal to 7x to the 5th. That's what I get if I go through and I divide everybody by x to get it in that form. They say, well, what is p to the x? P of x is this right here. So let's see, what is my integration factor? It's going to be e raised to the integral of 6 over x dx, which is the 6 you could take outside and integrate d over x, which is the natural log of x. So this is e to 6 natural log of x. And using a logarithmic rule, I can use the 6 and knock it into the power, and that becomes e to the natural log of x to the 6, or just x to the 6. This becomes my integration factor that I'll multiply everybody by. So when I did that, I get x to the 6th y prime plus 6 over x times x to the 6th is 6x to the 5th. Y is equal to 7x to the 11th. Now, it looks slightly different than it did. What I did was I already had an x, so I didn't need to multiply by x to the 6th. I multiplied by x to the 5th. That's the only thing different that I did right there. You don't have to start at x to the 5th. You could start by doing what I did. Clean it up, recognize your p to the x, multiply by x to the 6th. Then you would say, oh, this right here is the derivative of two functions, and integrate from there. So what did we just do? Then I got all the same stuff right here. Okay, what do we just do? In general, how do we solve a linear differential equation? Get it in this form. Recognize that that's what you're dealing with. Okay, identify p of x. So we identify p of x. And then we, so if I was going to write this in steps, okay, get your linear differential equation into the form dy dx plus p of x, y is q of x. All right, number 2. Find your integration factor. Find I of x is equal to e to the integral of p of x dx. Multiply both sides. By I of x. All right. And then integrate both sides. Solve for y, or the function. Or the function. All right, very good. So here we go. Here's our first real one, okay? So if this is what we're given, like, hey, what am I dealing with here? Can I get this in the form dy dx plus p of x, a function of x times y, is equal to another function of x? Well, I have the dy dx. I need a y function, so I'm going to move this over here to the left. So I'm going to rewrite this as y prime plus y is 5x. And then this is in the form, what is p of x? P of x is equal to 1. All right, so my integration factor is going to be e to the integral of 1 dx. Well, that's going to be e to the x is when I integrate that. That's what I'll get. So this is what I'm going to multiply both sides by. So I get e to the x y prime plus e to the x y is equal to 5x e to the x. I recognize this as the derivative of the product of two functions. So it's going to be first times the derivative of the second plus second times the derivative of the first. This is the derivative right here. I integrate both sides. with respect to x. And when I do that, I get on the left, I'll bring it over here, I get e to the x y is equal to, oh, I need to integrate 5x e to the x. So all of those integration techniques we worked on are going to come in handy now. We have to integrate 5x e to the x dx. This is a by parts. I'm going to let u be 5x. I'm going to let dv be e to the x dx. The v will be e to the x, du will be 5 dx. This is uv, 5x e to the x minus the integral of v, 5 e to the x dx. When I integrate that, I get, finally I'm going to integrate, and I'll put the integration right here. 5x e to the x minus 5 e to the x plus a constant. That's what I get right there. So solving for y means I'm going to go and divide by e to the x everywhere. Y is equal to 5x minus 5 plus c e to the negative x. And that is the solution to my differential equation. All right, a few more examples. Let's look at example 2. Before I do that, I want to say what form am I trying to get this in? dy dx is equal to, plus y times some function of x is equal to some other function of x. This is what I'm shooting for. So if I look at what I'm given, it looks like it's in that form. I have a y prime plus y times a function of x is equal to another function of x. All right, it came that way, so that's nice. P of x is equal to 1 over x. So e to the integral of 1 over x dx is e to the natural log of x is just x. My integration factor is x. So x y prime plus x times y over x is y is equal to 23 over the square root of x times x will give me 23 times the square root of x is what I get. Then I recognize this as the derivative of the product of two functions, first times second. First derivative of second plus second derivative of first, that is indeed what I have. I want to integrate this side. All right, this has x to the 1/2. Right. When we integrate the left, we get x times y. When we integrate the right, we get 23 x to the 1/2 plus 1, 3/2, divided by 3/2 or times 2/3. We get xy is equal to 46 over 3 x to the 3/2 plus constant. Divide both sides by x, we get y is equal to 46 over 3 times the square root of x plus c x to the negative 1. And this is our solution to the linear differential equation for that one. Okay, let's look at number 3. We want to solve this, which means find a function. Now we're given t's and r's. R is the dependent variable, t is the independent variable. So if you're thinking in terms of x's and y's, r is your y, t is your x, so to speak. So we want to get the dr dt by itself. So what I'm going to do is I'm going to divide everybody by t natural log of t at first. So I get dr dt plus r over t natural log of t is equal to 3t e to the t over t natural log of t. So did that help? Let's see, these t's will cancel. Now I have dr dt, all right, plus a function of, I have r times a function of t, which is basically y times a function of x, is equal to a function of t, function of x. So that works. So our p of x, so to speak, in this case is going to be p of t. So we want to integrate, our integration fraction is going to be e to the integral of 1 over t natural log of t. All right. This is going to call for a u substitution where we let u equal to the natural log of t and du is 1 over t dt. So really we're integrating dt over t. I get that by the du, and I have 1 over u. So when I integrate this, I get the natural log of u. All right, so my integration factor in terms of t is the natural log of u, which would be the natural log of the natural log of t. All right. E raised to the natural log of the natural log of t is simply going to be the natural log of t. So this is my integration factor I multiply everybody by. So when I do that, I have dr dt times the natural log of t plus r over t times the natural log of t times the natural log of t is just going to be r over t is equal to 3 e to the t over the natural log of t times the natural log of t will just give me 3 e to the t. I recognize this as the product of two functions, r times the natural log of t. First derivative of second plus second derivative of first, that works. It's equal to 3 e to the t. Now we want to integrate with respect to t. So on the left, I get r natural log of t. On the right, I get 3 e to the t plus a constant. To solve for r, I divide both sides by the natural log of t. My function that will solve this equation will be r, or r of t, is equal to 3 e to the t plus a constant divided by the natural log of t. All right, 2 more, and then we got it. Let's see here. Solve the initial value problem right here. T du dt is equal to t squared plus 3u. For t is greater than 0, and where the initial value u of 3 is 18. So they gave us this. All right, so let's look at this. To get it in the form, we need u is the dependent variable, t is the independent variable, and we need the derivative du dt by itself. We also need a function of, we also need a u by itself over here. So we'll see what we can do with that. To do a little bit of algebra is what we have to do. So let's see here. We will say, first I'll divide off by t everywhere. So we get du dt is equal to t plus 3 over t times u. All right. Now that got this by itself. Now we need u times a function of t. So I'm going to move that guy over here. So we get du dt minus 3 over t u is equal to t. All right, cool. Now we have that. We have a u times a function of t. The integration factor will be e to the integral of negative 3, I'm going to pull them on the outside, 1 over t dt. So that's e to the negative 3 natural log of t, but we can use product, the log law that says this is e to the natural log of t to the negative 3. So really t to the negative 3 is our integration factor. So du dt times t to the negative 3 minus 3, this is going to become u times t to the negative 4 is going to be t to the negative 2 when I multiply both sides by t to the negative 3. So I'm running out of room, so I'm going to have to borrow some space down here. This is a u, okay. This is the derivative with respect to t of u times t to the negative 3. We'll check that out. T to the negative 3, derivative of u plus u times derivative of this would be negative 3 t to the negative 4. That works out. So this is equal to t to the negative 2. Integrate. This gives us u, t to the negative 3 is equal to t to the negative 1 divided by negative 1 plus a constant. U is going to be negative t squared plus c t to the negative, or to the positive 3. Let me see if I did that right. Yeah, I did. So if we have this initial value where u of 3 is 18, let's get 18 is equal to negative 3 squared plus c times 3 cubed. I get 18 is equal to negative 9 plus 27c. If I add 9, I get 27 is equal to 27c. C is 1. All right, so our function, finally, for this one will be u of t. U of t is equal to negative t squared plus 1 times t cubed. And that is our function with the initial value. All right, last one. Solve the initial value problem. X, y prime plus y plus 3x squared sine of x, given that y of pi is 0. Here we go. Let's put it in the standard form to recognize it as a linear differential equation. So I'm going to divide off the x so that I can see the y prime by itself, and I get that y prime is equal to y over x plus 3x squared sine x divided by x will just give me 3x times the sine of x. All right, now I'm like, can I get it in the right form? I need to get y times the function of x on the left. So let's see, that's y prime minus 1 over x times y is 3x sine x. So now I have y prime minus y times p of x is equal to q of x. So p of x is negative 1 over x. So e to the integral of negative 1 over x dx is my integration factor. So that's going to be e to the negative integral of dx over x, e to the negative natural log of x. Using log law, this is e to the natural log x to the negative 1. So 1 over x is my integration factor. So if I multiply both sides of this by 1 over x, 1 over x y prime minus 1 over x squared y is equal to 3x sine x divided by x will just give me 3 sine x. This is the derivative of this function times this function. Let's see, negative x to negative 2. Yep, that works. Is equal to 3 sine x. Let's integrate both sides with respect to x. On the left, I get 1 over x times y. On the right, let's see, the integral, what gives me a derivative of sine is going to be a negative cosine. So I get negative 3 cosine of x plus some constant. Solve for y. Multiply both sides by x. Negative 3x cosine x plus cx. Okay, the initial condition is here. So when x is pi, y is 0. So we get 0 is equal to negative 3 pi cosine of pi plus c times pi. All right, I'll move the c pi over here. I get negative c pi is equal to negative 3 pi. The cosine of pi is negative 1. So I get that 3 pi is negative c pi. Divide by pi, or negative pi, I get c is equal to negative 3. All right, my function y is equal to negative 3x cosine of x minus 3x. That is the function that will solve this linear differential equation.